Assalamualaikum and very good morning to all. And it's very good morning today. Every morning, whenever I start class at 8 a.m, it's a very good morning because I have to travel from my house to here. I've come across Pantai Sepat every day. Have you been to Pantai Sepat? It's a very beautiful beach actually. I don't know, before this, I used to have to travel to Terengganu. Terengganu have very beautiful beach, but it's actually the beach is quite short. Okay, but for Pantai Sepat, I think it's about 1 kilometer. Okay, 1 kilometer. I think it's quite long. And then you can see the tree is being planted. I mean, it's planned to have such of design. Okay, so until here, so we have actually a design area. We have very beautiful arrangement of the trees. So and then but the only thing is back at long time ago, there's a lot of rubbish around. So our authorities have did a good job. So every morning collect the rubbish and make sure everything clean. So after that, now Pantai Sepat become very popular, and everyone comes to Pantai Sepat. They even have a camping site, sleep overnight. You have to try because they sleep overnight. So when you can enjoy a sunrise, very beautiful sunrise. So it's a good morning for me, and that is very motivated to come. But okay, so we continue with our topic for today. We have to see this uncertainties. Okay, whenever we do measurement, of course, when we do measurement, there always be uncertainties. There's no way that your sensors is very precise and very accurate. There's no way. Even your own sensors that built in your body. So we also have uncertainties. Old people, they have uncertainties. Sometimes they didn't hear. Sometimes they listen the words differently than us. Okay, and then I don't know, maybe kids have better than us in terms of the accuracy of listening things, precision. Okay, a few things that we always see in our measurement: precision, accuracy, and then what else? Repeatability. Okay, repeatability. So all these things that have a measurement to give the numbers value on these uncertainties. So when we buy sensors, you look into your if you go to Lazada or Shopee or eBay, you want to find the sensors, you go to spec sheet, you see there's always have these values, these uncertainties written in the spec sheet. Okay, so like I said, every system, not only sensors, every system have its own uncertainties. For example, if they claim this room have aircon, the room have aircon and it will give certain temperature for us, but that temperature have uncertainties also. It claim that in the aircon, it said that we will give a 28 degrees Celsius, but when we check with different sensors, it will give some uncertainties to the value. So even the aircon system in the room also have uncertainties, not only for sensors. Okay. So we engineers always talk about this. Okay. So okay. So this is actually the official word definition of all these things. But like I said, it's not about you memorizing the sentence. It's about how you understand and how you elaborate all these things in your own word. Okay. This is all textbook works. Okay. Okay. So this is actually 5 common First, we have hysteresis. This hysteresis uncertainty because of hysteresis error. Due to hysteresis error, there is we call uncertainties in terms of hysteresis. And then linearity. We have error in terms of linearity and also causing the uncertainty. We have sensitivity error. We have zero shift. Zero shift means the offset or bias or whatever. Basically it's a systematic error. Zero shift error is a systematic error. And then we also have this is actually data scattering. So most of the time we discuss hysteresis, linearity, and sensitivity error. Most of the time. I mean, if you Google right now, if you have time, you Google, you find, for example, microphone, or not microphone, accelerometer, or you find a temperature sensor. You find in the spec sheet, they are also always mentioning about the hysteresis and linearity and sensitivity error. Okay, so how we define as hysteresis? Hysteresis is actually when it occurs when the output of the measurement system is dependent to the previous one. So if you do measurement, you do let's say measurement to one side. So this measurement, for example, you pressurize the pipe. You pressurize the pipe. Suppose that when you pressurize the pipe, the pressure increase, and then when you depressurize, suppose that the pressure will decrease at the same rate. But due to the maybe some physical things happening in the pipe makes that create some sort of memory to the system, so that when you decrease the pressure, it will not going to the same path as you have done for the pressurized. Okay, we'll see the graph later. But the most important is you have to memorize this one. The uncertainty is the uncertainty level. Okay, if you still remember the error, before this we have shown the error equation. It always the upscale minus the downscale. Upscale, for example, pressurize. You pressurize, you upscale value, and then you depressurize, it downscale. Okay, so sometimes when you pressurize, it's not going down and up. It going sorry. Usually we go upscale, up and then down. Sometimes it's go like this, down and then go back upscale. We'll see the graph. Where's the graph? Oh, here. It's here. Okay. I will make it larger so that you can see clearly. Okay. Okay, so look at this. This is hysteresis. This is what I'm talking about, the up and down. So upscale and downscale. Okay. Sometimes it go this one up, this one down. It depends on the situation. The most of the time when we go up, it's moving to upwards. The value moving upwards, and then if downscale, the value moving downwards. It depends on our measurement. For this case, upscale is on the bottom one, and then downscale is the top one. So the difference between downscale and upscale is hysteresis. The difference, every x point have its own hysteresis value. But when we say uncertainties, we choose only the maximum hysteresis. So the maximum one occurs always in the middle. The maximum one, we say this is the uncertainties of the measurement of the sensors. Okay. You choose, for example, you choose a pressure sensor. I use pressurized pipe kan. The pressure sensor that you use to measure the pressure inside the pipe, you do experiment. You give let's say 1 bar up to let's say 20 bar. You go and then you measure the pressure. Okay, measure pressure from that pressure sensor. You can see that usually it goes one side and then go back to the other side. You repeat the test for let's say 10 times. It will always go the same direction. So that's mean that your sensors have suffer the hysteresis uncertainties. Okay, the smaller the gap, the better the sensor lah. Okay. So we go back to the oh, too much. Okay. So go back to the hysteresis. Okay, so this one, uncertainty U, the little words there showing the hysteresis. Uncertainty in terms of hysteresis. Okay. Usually in the few semester before, I always ask the questions in the midterm. What is definition of hysteresis? Okay, some people draw the graph, then explain. Some people showing the equations. I mean, it doesn't matter as long as you show that you understand what this hysteresis is, then you can get the full mark. And then this is actually okay. This is a percentage of uncertainties. So you choose the maximum one. This one, upscale. Upscale minus downscale. And then you divide by RO. I remember I have explained about the reference. This is a reference value. Okay, we will use either full scale output or full scale input. Remember? Okay, FSO or FSI. Okay, so RO range is actually depend on our definition. If we say FSO, and then you have to find the range for the full scale output and times by 100. So you get the percentage of the hysteresis. Okay. Please see this note. Hysteresis is normal for any system. It's normal. Okay, it's normal. Of course, when you pressurize the pipe will have some memory. If we release, it will release not in the maybe because of the pipe is not elastic enough, so it have some plastic memory. So that's why it's happened hysteresis. Not only because of the sensor. Sometimes the sensor have diaphragm. The diaphragm also, when pressurize the pipe, the diaphragm also try to make sure it stays at its position before it's release the pressure. So it's because of the system itself. So that's why you said the hysteresis is normal. It's happening everywhere. The only thing that we can reduce the effect of hysteresis lah. Okay, because if the hysteresis is so big, so it affect the repeatability of the system. Okay, it will give some sort of errors to the reading lah. So that's the hysteresis. Now we move to the linearity. Linearity, the same things. The uncertainties, the absolute uncertainties, linearity, okay, is equal to x, the measured value minus the linearity. Okay, linearity. The linear value. Okay, I will show you in terms of graph. Again, we go back to this one. So if you see the linear error, you see the dot one is the measured value. So if you do curve fitting, if you do Excel curve, you do curve fitting, it will give the linear line. So that linear line is give the linear value for that measurement. So the difference between the measured value and the linear line, which we call the linearity error. Okay, linearity. So again, for this one, we find the maximum value that the maximum error in terms of linearity, and that we give that one is uncertainty. Our okay, and then you find the maximum one, the maximum value that deviate from the linear line, and divide by again the range FSO or FSI depends, and times 100, and you get percentage of uncertainty in terms of linearity. And same goes to the this one different. The repeatability is different. Repeatability, you use different equation. Same, you divide by the range, but this one is Sx. What is Sx? It's the standard deviation of the system. Okay, again, when you do measurement kan, you do a lot of data. You process the data, you take the data, you find the standard deviation of the data. Okay, you find the standard deviation of the data, and then you times 2, divide by the range, and times 100, and then you got the percentage of uncertainty in terms of repeatability. Now we have 3: hysteresis, linearity, uncertainty. All of them, they use the same concept, which is the difference between data, the randomness of the data, divide by the range, and then times 100. They have the same equation. So I mean, you don't have to memorize lah. You can think about it. It's easy to see. Okay, so again, you see other than, for example, sensitivity error. Okay, of course you have data, you compare with the sensitivity value, you find the difference between each data. So you divide by range, you times 100, so you get uncertainty for sensitivity. And then same goes to the other uncertainties lah. Same concept. So if you have a lot of uncertainties, okay, it's not percentage, it's uncertainties, not percentage, it's uncertainties. So all this uncertainty value, okay, you time square, and then square root all this value inside the uncertainty ni, okay, and then you got the value for overall uncertainties. Okay, so if you go to the spec sheet of sensors, okay, when the boss say, okay, so how about these sensors, so can you recommend sensors? So you mentioned that you choose all the sensors, and you said to the boss, you said among all these things, the overall uncertainties, the best one is A, B, C. So you arrange in terms of the uncertainties value, because uncertainties give the how good your sensor is. Okay, of course we want the uncertainties to be as low as possible. All right, was that clear? I think that one quite straightforward. Okay. So when we talk about measurement, I have mentioned in a few class before, when do measurement we have a lot of standard. We have in terms of length, we have SI units, we have imperial units, we have US style, okay, we have foot, we have cm, meter. All these things have their own standard. So depend on us which one we want to use. The only thing is we have to familiarize with the conversion factor, conversion units. Nowadays it's easy. If you want to convert value, just go to Google, type conversion from what to what, and then it will give you the online solution. So nowadays it's quite easy lah. The only thing is we have to understand that which unit that we want to use. That's why in your solution answers, okay, you must put the units. Is compulsory. Okay, if not, I will give 0 marks. Okay, yeah. I'm serious about this one. I'm serious. You must give units in any measurement. In any measurement, in any numbers that you put, you must include the units at the back of the numbers. Okay, there's no numbers value without units. when we learn physics and we will learn engineering. Even the micro strain, you know micro strain, good, you know strain. Strain is the pemanjangan, the okay, extension divided by the original length. So both of it have the same unit, isn't it? So it cancel out. Still we call it micro strain. Strain. We write down as it's not unit, but it's showing what kind of numbers is that. It shows something like this. Micro strain or micro strain. It is a dimensionless unit, but still it's a unit, something that we show that the number is referred to something. So it's very compulsory. Yeah? I'm serious about it. Kalau tu apa? Kalau orang serius ni, saya teringat bila sebut serius ni, saya teringat cerita Pok Ayah, contoh dia, muda primula. I can slap you whenever I want, wherever I want, whoever I want. Muda primula. Saya boleh tapar awak mana-mana saja, siapa-siapa saja, bila-bila masa. If I can do that, for those who are not writing the dimension unit, and then I will do it. Kalau boleh lah. Tapi saya bukan muda primula lah. Okay, now this is how seriousness of this one. The most important is the unit. So this is actually the units is actually written here. We used to memorize this one before this. Okay, we used to memorize all these things, the conversion units. Okay, engineers always remember this one. At my time there's the internet, Google is not really handy, but now it's handy. Even you use your watch, smartwatch, it's very cheap. You can calculate. Okay, this is a derived unit. Usually derived unit is referred to the parameters. So but it still you need to write down the units in your calculation. One other thing that's important when you write down your answers is actually the significant numbers. The significant numbers, because you are calculating. To make sure that your calculations is the same as what I've done in my calculations. Make sure you use at least three significant figures, or if in terms of points, decimals, choose at least 3 decimals. Okay, yeah, the maximum is 3 decimals. Do not choose more than that. 3 decimals. Okay, 3 decimals. Because if you use a calculator, it will give you a lot of numbers, isn't it? Up to 12 decimals. So just take about 3, and then you can include do your calculation. Okay, this one I give further. Okay, this one usually people make mistakes in terms of writing the prefix. The prefix. D deci is the small d. They put a capital D. So one says a mistake. So make sure the writing is correct. Okay, mega, usually mega is symbol is M, prefix is mega. Okay, it's a small M. Okay, then giga, small g, but the symbol is big one, the capital M. The symbol for giga is capital G. Okay, so this is on term of writing. Okay, so this is actually a question, a very popular questions that we ask. What is the purpose of calibrations? Why we need to calibrate? What is happening? What is actually what it tell us? If you see the system is being calibrated, what it tell you? So actually the answer is already written here. That's why whatever I put in the notes actually is not will be in the exam lah. but it can be an example of how I ask the questions. Okay. So the calibration is actually to show that the system have been evaluated, which is the output and input is being recognized. The value, the input is given and the output from the system, it have its own, it's established already. Okay, you have an established relation between both those. Okay, sometimes when we do testing, pressure transducer, all the time when we do measurement, sometimes it's the diaphragm being distorted. Okay, so we have to recalibrate, make sure that value can give the accurate value. So most of the sensors, they said every year we need to have a calibration for the value. Every year they will give a different sensitivity value lah. But of course, if we sometimes we don't care about it because it's expensive to calibrate the sensors. So for me, I just use whatever I have, and I do my own calibration. The most important is here, the ISO 9000 certificates have a strict rules on the calibration results. For example, we have here tensile test machine, our own tensile test is being used by Petronas to test their own samples. They have samples, they go to us, but the validity of the samples, it depends on the calibrations, how we do calibrations. Okay, because when we pull the sample, you know, tensile, when we pull the sensor, when we pull the specimen, it will give the strain value. So how can you tell the accuracy of the strain value? How can you tell? It depends on the calibration data lah. So if not calibrated, so the strain value that given by the tensile machine is being questioned actually. So that's why we have to have, every year we here in our faculty spend about ringgit to make sure that our system is being calibrated, because we have customers from Petronas and so on. Okay, so if you have your own customer, please make sure that the system is being calibrated lah. So now we moving to the another topics. Okay, I think the last topic that we will discuss about this fundamental is the random error and statistics. Okay, so this will involve a statistic value. Just now I just mentioned about the standard deviations. It's one of the statistical value, SX, standard deviation. But now we're moving to the bigger one, larger one. We will use two kind of statistical calculation, statistical information, which is from the normal distribution and student T distribution. Ingat tak? If you remember that one, remember the normal distribution? Statistic, ada yang belajar tak? Have you learned this one? Kan, matematik kan? So we will use that one in this subject to find the uncertainties of the measurement. Okay. Okay. Now we try to memorize. We try to go back to the terminology. The variable. Now the variable. Remember the variable? The value that varies. Now we map it to measured to the we in this one we call it measured variable. Okay, and then or we can say it's measurand. So whenever I say measurand or measured variables, it's actually a variable that we measure. Okay. All right. Now we go to the next one. We have we have a lot of statistical distribution. All this distribution actually refer to the infinite measurement, infinite, or large data, very large data. For example, our Malaysian population 30 million. Yeah. So that we call a very large data. So we use a normal distribution, infinite data. So basically, if we have a normal distribution, usually we want to find Okay, all of this tells us the randomness of the data. Okay, the randomness of data. This is actually a log distribution, Poisson distribution. All of these have its own equation. This equation is based on, for example, the statistical distribution. This equation is based on the value, the mean value, and the variance value. So that's why from this distribution we can find the variance and its mean value. And the same we have mana lagi lah, we have Weibull, we have binomial punya ni. Alright, so we will not look at all these things except we look at the normal distribution lah. Okay. In this equation, x prime is referred to the mean value, and this sigma refers to the variance. Okay, in the equation. Alright, so that equation actually it formed the curve. So our task here is to find the value as the in the curve. Through the curve we need to find the value. Okay. If you look at the x-axis, we have z value. Okay. Z value is mapped to the b-axis, which is b is tell us about this one, x minus x prime over the variance. That tells us the b-axis, and each value in the b-axis is z1. Is z1. Okay, every value in the z-axis is z1. Okay, so z1 is dependent on x value lah. So x value. So if z1 move towards the end of the axis, x-axis, this one also different. The x value also different. So our goal is to find mean and variance so that we can find the x. Okay. Alright, so you don't have to worry much because we have the table. So for each x1, you know the mean value, you know the variance, you can find the z1 easily. Okay. Or if we given the z1, we know the mean, we know the variance, we can find the x1. It's either one lah. So, right. Okay. Let us look at the example. Okay. Now we go to the term of uncertainty. Okay. Now we go to the term of uncertainty. Let me this one. Alright, always when we buy sensors or we do a lot of measurement for large pool of data, always we found something like this, A plus minus like A. For example, if it's about length, so we get it like cm. We always have something like this. So this is actually the value. So this is actually the uncertainties. So the smaller value of A is the better. So okay. So this is actually the range, meaning that the value can be from A plus A or A minus A. Okay, the value can ranging on this one. For example, macam ni lah. So if you have so you have A here. Okay, you have value A plus A minus A. So probably the data will be around this one, something like this. Faham? Remember? Okay. Okay. So this is what it's all about. If you look at the statement over there in the slide, so this is actually all about. So we have the mean value plus minus. The A here is referred to the Z1 times variance. Okay, so variance is given, or sometimes you can calculate, and Z1 you can find from the table, or easily you can find that Z1 is equal to X1 minus mean over the variance, kan? Right? Okay. So, alright. So now, so the probability of the data, this is the data distributed in the curve here. The probability of the data to appear in that range is 2 times PZ1. What is PZ1? What is PZ1? PZ1 is from the this one. From the table nanti. Kita akan tengok nanti. We will see the example later. So it must times by 2 and times 100, so you can get the percentage. Okay. So we look at this example. Okay. Now, if you look at the example, from the table 4.3 is our own table. Maybe you can refer to your table later. Z1 given equal to 1, Z1 equal to 2, and Z1 equal to 3. Find this range. For Z1 equal to 1, Z1 equal to 2, Z1 equal to 3. Find this range. Okay. Find the P, P depan. Probability of the value appear in the range. In the range for A ni, Z1 equal to 1, Z1 equal to 2, Z1 equal to 3. What's the percentage? Okay, now we see how we calculated. Okay, from the table, Z1 1, Z1 2, Z1 3 is equal to that value. Okay. Okay. Straight away you can find that one, and then you must times by 2. Ingat equation tadi, you must times by 2, then times by 100, and then you can find the percentage. So for Z1, the percentage of the data appears in that range is 68.26, and for the Z1 equal to 2, the data appear in the range is about 95.45. So if data Z1 equal to 3, the probability of the data to appear in that range is about 99%, about here to here. Okay. Alright. So usually we want to find, of course, we want to have a Z1 equal to 3 lah. Okay. Tapi if you look at here, most of the reliable data appears in this range. The other one is just, for example, this part is very small, small value here. Okay, now we look at more example. Tapi saya nak stress kat sini. So I padam ni. Most of the time we fail to relate the theory to the actual things that we got from the measurement. For example, what is actually Z1 tells you? It tells you that whatever value, let's say A plus minus X that one. Okay. So if this one equal to 1 means, what do you mean? Equal to variance lah, kan? Faham? See? So if A plus minus Z1 variance, Z1 equal to 2, which mean that it's actually 2 variance or 3 variance. Okay. So for this case, for 3 variance, it appear 99%. Right. If this one appear 95%, and this one about 68%. Kan? Betul tak? Of course lah, if the range big, you can find data, the confidence level of data you can find in the range lah. If the range is big, if the range is small, this one is the small range kan. Of course you can find a little data lah. Okay, that's the logic in terms of this one. Okay, now boleh nampak it's quite it's not really difficult to understand that one. That one in terms of infinite data. So basically you already know the mean value, you already know the variance, and you just want to find the probability of the value appear in the data set. Okay, now this is involve the calculation. This one easy to make a questions. This one easy to make questions. Basically easy to make a question in the midterm because it's finite data. When we say finite data, it's about, let's say 20 data, 30 data, it's finite numbers. Just now it's a very large pool of numbers, so if we call it infinite data, so different table we use. That one we call table for probability for the normal distribution. Okay, table 4.3 normal distribution. But if we have a finite statistics, we need to use a different table. Okay, let's say we have n value 1 to 20 for example. So we will use this equation. Okay, this equation. So for normal distribution, the infinite distribution, you have to memorize this one. You have to memorize this one, and you have to know where is Z1 and where is X1 and which one is P. What is PZ1? Okay. So for the finite, this one is the equations. First is the equation for the mean value, equation for the variance, equation for the standard deviation. Don't worry, this one will be given in the exam lah. Kalau masuk exam lah. If in the exam, I will give this equation. It's not possible for you to memorize this one. But actually it's easy to memorize. Tapi yalah, no worries. Nowadays we can use Excel. That's why I just this is just for example, just for the practice for you to calculate the calculation. So easy. If for mean simple, you add up all the value and then divide by the numbers. And same this one, the numbers minus the mean, you square, and then you add up everything, you divide by n. The same for this one, the only thing is just square root lah, square root value for this one. So I will always do this in Excel. But for you, in exam or in assignment or in quiz, you have to do by using your own hand. Okay. And again, the objective of why we looking at these things, actually we want to create this one lah. This one. We have to look the value, which is the value is given by. This is actually for the confidence interval. Okay, I have to write down this one. So when we use a finite data, what we find? So we have, let's say, we have 1 up to 20 data. Okay, so it will give us like the value of mean plus minus t for this one is z kan. So for finite data is t p apa tv Poisson v p times s x. Okay, so this actually for the conclusion of the data. If you have 20 data, you can conclude something like this, something like this. Okay, this equation, if we don't know the value for, if the mean number, usually the mean number is fixed based on the data. Okay, but if you repeat the measurement, there's possibility of the mean also different kan. Data kan 1 to 20 not always the same kan. So let's say one batch 1 to 20 data we take and we calculate the mean. Okay, one mean, and then we repeat the same with the same batch. Then we have second batch of a mean. Okay, and we have third batch of mean. So the mean number always will have a different value, varies. So to track down the behavior of the mean value, we use this equation. We call it x prime. Okay, x prime given by x bar plus minus t vp s x prime. So s prime ni adalah the variation of, kalau x is the variation of data for this batch. Okay, the variation of data for this batch. But for x bar ni is the variations of mean. Variation of mean. So I have two things here. First, the range of data in that finite number, and the other one is the range of data if we repeat the data and we have uncertainties or in terms of the mean number. Okay, so we have first one and we have second one, but the problem is, what is TVP? Okay, so of course this one we know, standard deviation. Okay, but TVP over P is actually a student distribution value. So this is student deviation, table 4.4, student T distribution. So V is the top one, V is the column, and then the P is the rows. So V, you choose V. Okay, we call it degree of freedom of the data. So if we have a lot of data, we have a lot of degree of freedom, and then we have the probability, the confidence level. T50 means 50% of data. We confident level. We confident that the 50% of data appears in the range. And T90 means that we confident the data will appear in that range, 90%. And 95% will appear in the range, so we call it T95. So this is a probability lah. So this is a probability. T99 of course the largest one is given as this one lah, as that column, the last column. So of course we have to see the example. Okay, consider that we have this one. Again, this one you can calculate using Excel, easy, using Excel. You have data here. You have data, and then 20 data, 0.98 until down here. So from here, which one is the maximum number? 1.34. This one. This one the maximum number. The lowest one is the 0.86. So we can say that if I can conclude this one, this data will be in the range of mean. I don't know. You have to calculate the mean. You have to calculate the mean plus minus, or say from 0.86 to x bar to 1.34. This is the range of data from here to here. Okay, from 0.896 to 1.34. Okay, in the middle is the mean. Yeah. Oh, 0.6 ada lagi dah. Nombor 6. Oh, ada lagi. Sorry. Sorry. Okay. Oh, besar range ya. Right. So this is actually actual range. This one as the actual range. Okay. Value appear inside in the range. But what is the percentage of data? If we pick the data, it appear in that lower range than this one. Ni full range. Ni 100% range. 100% range. Of course, if we pick data, we can pick all the data. We randomly choose the numbers. We can have all the numbers. 100% confident we can pick all the numbers. Okay. But how if you want to change to 95%? So if 95%, which range number? If you want to choose 99%, what's the range of the numbers? 50% range. Okay, so now we do calculation. So first you have to find a mean. Okay. I always said compute the statistical information of the data. So statistical information of data which we have mean, maximum value, minimum value, kan? Apa lagi? Standard deviations or variance. Okay. All this is a common statistical information of the data sets. And then estimate the interval of values over which 90% of the measurement of the measurement should be expected to lie. Maknanya, of course 100% is this range. But how about the 95%? How about the 90%? So we calculate. And we have a C. Di sini nanti kita tengok kemudian. Tengok ni dulu. So estimate the interval of the value. Okay, for 95% probability. So of course you calculate the statistical information. For me, I use Excel. For you, you calculate manual. Now you have mean 1.02. Okay, now we know 1.02 lah. So x bar. So x bar 1.02. Okay. Now the x-axis berapa? 0.16. Okay, 0.16. So we have this one. You already have this one. We have this one. Now we have to find this one. So we know that given 95%, it's 195%. Then value V is equal to n minus 1. N minus 1. Kan? So you refer to the equation, to the table. Go to the table. Table 4.4. So n minus 1 is equal to 19. P is of course referred to the T 90 lah, 95, because it asks for 95%. So go to 95%. So which one is 19? Here 2.093. So T VP is equal to 2.093 kan? Betul? Betul lah? Alright, so easy, just plug in the numbers. So for example this one 1.02 plus minus 2.093 times x is 0.16. So how much boleh cerita range, berapa range dah ni? Somebody calculate for me, help me calculate the range. Ada orang calculate tak? Aduh. Silap kalau tertinggal. So what is actually the range? So basically the range saya tunggu ni. Saya tunggu. Saya tunggu ni. Saya tunggu ni. Tengok je siapa buat apa tak buat. Hati seorang abang dah. Kena selesai slide je. Selesai slide. Tak, saja dah test je. Kalau saya slide ni ada dapat tak? Saja je. Nak gurau pagi-pagi ni. Ya, semua ada apa sini. Aduh. Saja je. So the answer is, I don't know. When I ask the value, nobody tells me the value. Or you should tell me the value. 0.33 is easy. So 0.33 is the, and then you find it's about, let's say range is say apa? 0.69 to 1.35 kan? Okay, betul. So this is the range. 95%, it will appear in this range. Okay. Dia a lot bigger than the original one. Okay. So if next time we take data, there's 95% probability the data will appear in the range, in this range. 95%. Okay. It will appear in the range. Okay. For the third question is very tricky one. So of course, if we make more measurement, what happen? If we make more measurement, the value for mean will differs, isn't it? It will differs. So what is the probability of the variance of the mean to varies? So how to calculate that one? Simply use the equations I said just now. This equation. Use this equation. The only difference is this one. This one. How to calculate the Sx bar is this equation. Use this equation. I believe this one is not written. This kalau saya bagi soalan, if I give your exam, this one is not written in the exam lah. You have to memorize this one. Simple ya. Sx divided by square root of n. Simple. Okay. You can find the x bar 0.04 and then plug in into equations, and you can have the probability of variance. The probability of the mean also can varies with the measurement. Tapi small, very small lah, 0.01, 0.08 lah kan. Kalau if original data is 0.33, large range kan. Tapi there is possibility of the mean to move about 0.08, the changes. Okay. But that one is if you have 95%. But if we choose 90%, 99%, so different kan. Okay, so with that, I think I want to conclude my lectures for this first parts, the fundamental of the measurement. Okay, hopefully you can get some ideas of what's happening, what's actually how to choose sensors, what's actually the value tells us in the when you go to the spec sheet, what's the value tell us, and where this value come from. Okay, all these values come from this one, from the statistic calculations and also for the uncertainties calculation.